Welcome to part 2 of the Ragdoll tutorial. Right now we have all the body parts made, and we made all the empties, which are constraints. So right now I can go ahead and select one of the body parts and select the whole group, and I can make them active rigid bodies by clicking here. And now we can simulate those body parts, and right now you can see they're not attached and we don't have a ground, so let's add a ground first. Just add a simple plane, scale it up 100 times, then apply the scale so it becomes 1 again. This works better in physics simulations. And now we can add passive so that it is a rigid body and it stays where it is now. Okay, so now when we simulate, you can see those body parts all fall to the ground and go crazy. Okay, cool. So what I'm going to do now is add the constraints. Right now they're just loose pieces, but what we want to do is add constraints. And the way a constraint works is adding an empty at the pivot point of the constraint and then selecting the two objects. But because we already have empties, I'm gonna just use the empties we created so that they serve a double purpose. They are the bone constraint targets, and they are the rigid body constraints. So I'm gonna start with the neck. I'm gonna select this empty, and then I'm gonna go to the physics panel and click rigid body constraint. And right now you can see we have a type, enabled, disable collisions. I'm going to set the type to generic, and obviously I want to enable this, and I want to disable the collisions between the head and the body. This turns out to be a little bit more stable, and since we can set the limits, we don't really need collisions between those two objects. Okay, so for the first object, I always want to add the main object, so the sort of the parent of the two. So in this case, it's going to be the body. So I'm going to select, I'm going to search for Ragdoll body, or I think I called it torso. There we go. Torso, and for the second one, the head. Let's see. Okay, and the reason I want to do this is for later when I'm going to set the angle limits, it's a bit easier to understand what direction you're looking at. It really doesn't matter how you organize these objects. You can just as well switch these, but this is the way I like to do it. Okay, then we can set breakable if we want to break the neck for any reason. I'm not going to do that. I'm going to just leave all my constraints intact. And we can also override iterations, which means in the scene setting you have a solver iterations, and this is for all the constraints, the number of steps per, I think, per frame they use to calculate the constraints. And if there's a very weak or very unstable constraint, you can override the iterations and set more iterations for just one constraint. And now for the limits, right now it doesn't do anything. If we simulate to check, nothing really happens. So we have to set limits. At this moment I'm only going to set regular limits and not like translational limits, and no rotation limits. And I want to set these limits to 0, so I'm going to make these all 0. And now when we simulate and look a little bit closer, we can see the head is attached to the body. And we look at this from the side view. As you can see, the head is rotating around the pivot point, but it's still constrained to the body. Okay, so this is the basic setup I want to use. So I'm now gonna select all my constraints and all my empties and create constraints out of them. So here for the shoulders, add a rigid body constraint, generic. Object 1 is the body or the torso, and object 2 is the arm. Ragdoll arm up, right. And I want to set limits, set them all to 0. Second shoulder, and now the elbows. So now I want to set for the first object the upper arm, and for the second object the lower arm. Same thing for, and I'll set all the limits, of course. Same thing for the left elbow. Generic with arm up first, and then arm lower, the lower part of the arm. Let's check. Yeah. Now the hips. Basic, same as the arms. First we have the torso, and then the upper leg. Generic, torso, and upper leg, left. And the knees are similar to the elbows. I think I forgot to set the limits. Yeah. Okay, the knees are first the upper leg, and now, and then the lower leg. Upper leg left and lower leg left. And don't forget to make it a generic constraint and add the limits, all 0. Okay, we've set up all the constraints. And we didn't go into the settings quite yet, but if you now simulate, you can see they kind of work, and all the body parts are attached to each other, except for this one. And I forgot to set the limits, of course. So let's double check every limit. Yeah, so basically what this does is it's the translational limit. So in the X direction, it can move the second object in relation to the first object, can move 1 unit to the left and 1 to the right now. So I'm gonna 0 these all out for all the constraints, so that they can only rotate around the empties. I think the rest is good to go. So let's simulate one more time. Now you can see it's a really weird shape because every object can rotate in every direction. There we go. Okay, cool. Now before I'm going to go into the rotational limits, I'm going to set up all the bones to be follow the ragdoll. So let's look at the bone layer, and let's start with the head. So I'm going to select the head, and I'm going to go into the bone constraints tab. I'm going to add a bone constraint, and I'm going to copy transforms, and that's basically copy location, rotation, and scale all together. So I'm going to copy all the transforms of my first empty. So this empty, I want to copy the transforms of this empty because it moves with the head. So let's copy the name of this empty and go back to the bone and paste it in here. And now you should see it copies the motion of this empty. And the reason it stays here is it's still parented to the main bone. So once we set up all these bones, it will work. And yeah, so I'm gonna just move on and see what happens when I'm done. So select a faster way to set up this constraint is to first select the empty, then shift select the bone, and then Control Shift C, and then you can add a constraint and then just choose copy transforms, and now it has set up this constraint for us. Okay, so let's do the same thing over here. Control Shift C and copy transforms. Same thing for the left side. And for the body, I don't want to use this bone. I only want to use this one because it's the main control bone. And since I only have one torso object, I only need one. So let's seek, here's my empty. And it's still orange. The other ones are green because they're added to a group of constraints. So this is the only one that's not added to a constraints group because we don't need a constraint over here. So no worries. Now select the bone, Control Shift C and copy transforms, and do the same thing for the legs. I believe this is my, yeah, this empty moves with the upper leg, so this upper leg bone is the one I need. So let's do it this way. And there we go. Now let's see what happens when we simulate. You can see the skeleton or the armature moves exactly with my ragdoll. And if we enable Syntel, let's see what it looks like. And it looks kind of weird because the objects are moving all over the place. One thing I think I need to fix is the neck. I'm only using a head object for the ragdoll, and I'm not using a neck. So this is going wrong over here because the neck is being, the head is parented to the neck, and neck is not rotating at the moment. So if I select the neck bone over here, I'm going to add the same constraint. So first select the empty, the neck empty, and then select the neck bone, Control Shift C and copy transforms. And now it is a little bit better. And you can dial down this constraint. And this is before, this is after, so it's a little bit better, and it's still not exactly matching. And that probably has to do with some weird parenting. I didn't create this rig, so I'm not exactly sure how it works. But I think for this purpose it's good enough. And I'm gonna add more limits to this constraint, so the neck is not gonna be able to rotate that much. What I want to do now is add limits to the constraints because this looks just ridiculous. So let's start with the neck. I'm going to select this empty and go to the physics panel, and here you have the angle limits. This can be a bit complex at times, but right now I'm going to just enable them, and you can get a sense of what this is doing. In each axis, each rotational direction, it limits the rotation to 45 degrees left or counterclockwise and 45 degrees clockwise. So I think the first thing I'm going to do is just run through every constraint real quick and enable all these rotation constraints, and then let's look at the difference that gives us. Okay, I think I got them all. So let's simulate again and see what it looks like. Now you can see it's maybe from the side view you can see it. The knees are locked when at this point. The knees are or the legs rotated 45 degrees, so they can't rotate any more than this. So it looks a little bit more realistic. But it still doesn't look very good, so we can add a lot more improvement by taking a closer look at these values. So let's select the neck constraint and let's look at what this all means. So first you have the X angle, and the way I visualize this is when I have my first object over here and then my second object is the head. So I always look at the second object, or I always imagine the second object is rotating, and then when the x-axis is pointing to us right now, clockwise, this direction is the upper limit and counterclockwise is the lower limit. And the lower limit is always negative, the upper limit is always positive, because when we start, the rotation is 0. So when it rotates counterclockwise, the angle is negative, and when it rotates in clockwise direction, the angle is positive. And when you swap these around, or when you look at the other side of the x-axis, then this doesn't make sense, or it's the other way around. So it's very complex because we have two objects and two directions you can look at this axis. So the way I do it is look at the second object is, or imagine the second object is rotating, and then make the axis point at you or at your viewer, and then this is the main rule. So let's take a look. In reality, I think the head can rotate a lot, so maybe 45 in this direction is good, but in the other direction I want to limit this at 30 degrees, so we have a little bit less rotation. So let's look at other angles. The y axis is, so 45 degrees is about this direction. When this is straight, the head can rotate this way, that's about 45 degrees, and the same for the other direction, so this is pretty good already. And then for the Z angle, I think 45 is fine. We can do even more than this, but I want to limit the amount of rotation. Other body parts that have a really different kind of limits are the elbows and the knees. So let's take a look at the elbows. When you look at your own elbow, it basically only can rotate in one direction, and in this case it's the X direction. If you look at the rig itself, take a look at this arm and temporarily disable the constraint, we can rotate, and we can only rotate in one direction, and you can see this here. Only the X direction is unlocked. So let's re-enable this, and when we take a look at the constraint over here, we should limit the Y and Z angles to 0, because these directions are not able to, the arm is not able to rotate in these directions. And now in the X direction, by the way, I'm not looking at this properly. I should switch this to local. Now we have the proper axes, and maybe I did this wrong for the neck as well. So let's take a quick look. I can see my Y and Z axis are switched, but it doesn't matter because they're both the same. So be careful with this. You should be looking at your empty in local view, or make your empty even better. Make it arrows. And now you can see here that this is the x-axis, this is the z-axis, and this is the y-axis somewhere. But I like having colors as well. Okay. So now when we look at the elbow, the x direction is the only allowed rotation. And another thing, when we think of the upper arm as solid and the lower object 2 as rotating, and look at the x-axis, make the x-axis point at us, then we can see this direction is counterclockwise, this direction here, and the limit is set to -45. I think we can set this to -90, so we can rotate this for 90 degrees, and I think even more, maybe even -110, 110 degrees. But however, the other way is we cannot rotate our arm in this direction. Let me draw it. We cannot draw we cannot rotate clockwise. So I have to set the upper limit to 0 as well. Okay, I hope that's not too confusing. Let's take a look at the other elbow constraint, and it's exactly the same story. We can take a look at it from here, because then the x-axis is pointing at us, and it's exactly the same. So let's do the same, make the same values, -110, and the rest is 0. Okay, elbows are similar to knees, so let's look at a knee. And there we can see, when we point the x-axis at us again, and we imagine the lower leg is rotating, it can only rotate counterclockwise again. It's not able to rotate clockwise. So I think we can limit this to 90 degrees. So let's set the lower limit to -90 and the rest to 0. And I think, yeah, the other knee is has the same properties, so let's do the same, -90, and the rest is 0. Okay, let's quickly save and try to simulate this again. And what now happens is the body is more limited to certain rotations. And I think this is good enough. You can spend more time on the other constraints and make those values more realistic. But I think we will do fine when we do a simple simulation. And when we figure out it still doesn't work, we can spend some more time on this. So let's go back to the first frame. And one thing I want to do is go to the first frame, go to my first layer, to being able to select all these ragdoll shapes. And in the physics panel, I want to enable deactivation and start deactivated so that they don't move from the start. And I want to copy from active so that they all have this property. And to make the simulation a little bit more realistic, I can calculate the mass for every object. And what this allows you to do is it calculates the mass when an object is bigger, the mass is also bigger. And right now, since we copied from active, the mass for every object is 1, which is not very realistic. So let's calculate the mass for these objects. And I'm going to choose ice solid, because solid ice has a similar density to water, just liquid water, and I think liquid water has a similar density to a human body. So there we go. So what happens now when we simulate is when nothing happens, the simulation actually starts when one of these objects is hit by, say, a car, then the whole simulation starts. So let's go back and add a quick car on layer 2. On layer 2 we have the synthol, and when we refresh the frame, that weird glitch goes away. So when we add a quick cube, go to edit mode, move it up, and scale it down in the Z direction. What's the size of a car? I think about this. Okay. Let's add an edge loop over here. It's like these guys extrude. This is going to be a real quick car. Maybe just a very tiny car. Like this. Okay, good enough. Let's look at this from the side. Good enough. Okay, one thing to note is the simulations tend to be better when you have a nice closed mesh. So yeah, that's one thing you have to keep in mind. The rest is very simple. When you want to have a collision with a nice car model, a very complex car, I recommend you create a proxy shape like this around the car to make the simulation a little less heavy on the system and a little bit more stable. So now we have this car, and I want to animate it from the left to the right, just along the x-axis. So let's start it over here. Insert a location keyframe. Then move it up at, say, frame 50. After 2 seconds, it's going to be here. And insert another location keyframe. And let's look at the speed. That is about fine. Okay, so now when we simulate, nothing happens because we have to make this a rigid body. So let's add active, and now it's being simulated, so it just falls to the ground. We have to go into the rigid body settings and check animated to use the animation in the simulation. Okay, ready, set, go. Whoa, that's looking pretty bad. Wow, looks like we are on ice. She is sliding so hard. I think we have to increase the friction of the ground to make this a little bit more believable. So simply select the ground and add some more friction. Let's try to simulate this again. I don't need to see this ground. So there we go. That looks a lot better. So there you have it. A very simple ragdoll which allows you to create interactive simulations with your characters. And it's really fun to play with this and to throw your ragdolls off stairs, anything you can imagine that is not possible or that is very hard to animate by hand. Okay, cool. A final thing I want to cover is how to switch between your animated rig and your simulated ragdoll. So I already briefly mentioned this. You can play with this influence. So for example, let's take a look at Syntel. When she gets hit by a car, you can dial in and out this arm, and when you do this with all the bones at the same time, you can just dial between the regular shape of the rig and the simulated ragdoll. So a very nice way to do this is to create a driver that drives all these influence values. Yeah, the way to do this is to create a custom property which allows you to do this. So you can add a custom property to your bone, you can add a custom property to your armature or to your object. And I want to add this to my armature. So in the armature panel, let's go to the custom properties and add a new one. There we go. It's a default one, prop, and set to 1. Let's edit this and call it Ragdoll. Okay. I want to be able to drive all the constraints with this single value. So the way to do this is to first, let's take this bone as a start. Doesn't really matter where you start. The first thing I want to do after I added this custom property is to press D while hovering above this value, or just simply add a driver like this, and then it becomes pink or purple. It becomes purple, and there's a driver added. And the way to edit your drivers is in the animation panel in your F-curve editor. I don't need my my dope sheet, so I'm going to just move it up like this, and then you have a mode called drivers. So you need to go to driver mode, and then select your one bone, and we can see there's a lot of drivers. Currently, my influence is highlighted, which is the one I want to use. Copy transforms influence. And then we need to bring up this panel over here. And this is the panel you want to look at, so the drivers. And then you can set an expression. Currently this is set to 1, so the driver value is just 1. When we change this to 0.5, 0.5, it's set to 0, which is odd. Anyway, we don't want to do this. I'm going to add or use a variable, and here you can add a list of variables. You can remove them or add them like this, and I'm going to call this one the influence. Yeah, just influence. And then I need to add this over here as well. And instead of scripted expression, I want to just use average value. Okay, so now what happens is it takes the average of all your variables, and since we only have one variable, it's just going to take this value. And here we have to choose single property of some object, but in our case, it's a custom property of the armature. So instead of object, I want to set this to armature, and then what I can do is in the Ragdoll custom property, I want to copy my data path and then paste it in here, and it doesn't work. Wait, I first have to select my armature, and then I can paste in this custom property. Okay, there we go. So currently I'm getting a value of 0, which is odd. Let's update this. Okay, after I updated my dependencies, it works because now the value is 1, and when we change this, you can see it changes over here. So the driver value is updating as we move this. Okay, great. So now we have this one constraint being influenced. Influence is 1, so when we change this to a different value, you can see the influence is being changed. Let's go back to my default view and copy this driver, and I can simply paste this driver into every other constraint I want. So let's do the head, the neck, the arms, the lower arms, and finally the legs. This one I already did. And there we go. So now when I go to my armature and to my custom properties, I can change this value. So when you can see Sintel is being hit, you can change the values. You can change the value of this, and now she's just going to the default pose because I forgot to add. I forgot to add the driver to this main bone. There we go. So when I add a driver over here and go back, now you can see it works. So when you set the ragdoll to 1, Sintel is just following this ragdoll shape, and you set it back to 0, it's just the default shape. So this is very nice if you want to have some character walk across the street first with a walk cycle, and then follow the ragdoll as it gets hit by a car. This is the way to go. Okay, this concludes the ragdoll tutorial. This is everything I wanted to teach you. I hope you have fun, and thanks for watching.